Right now, in the middle of the Egyptian desert, water is flowing across a place where no water has flowed for 10,000 years. Not a mirage, not a flood, a river. A man-made river, carved by human hands, running in a straight line through some of the driest sand on the planet. It stretches for more than 300 kilometers. It climbs uphill. It crosses a plateau where the temperature hits 50 degrees Celsius, and the nearest drop of natural water is 100 kilometers away. At the end of it sits a machine so large it holds 4 Guinness World Records. It cleans 7.5 million cubic meters of water every single day. The price tag started at $5 billion. Then it kept climbing, 15 billion, and still going. Egypt is trying to do something the world's engineers said was borderline impossible. They are trying to turn 9,000 square kilometers of dead Sahara into green farmland, an area larger than some entire countries. And to do it, they had to build a river where rivers do not belong. This is how they did it. To understand why Egypt would spend $15 billion carving a river through sand, you have to understand a terrifying number: 95%. That is how much of Egypt's people live crammed onto just 4% of its land, a thin green ribbon along the Nile. Everything else is desert, and that green ribbon is running out of room. Egypt adds roughly 1 million people every 8 months. The cities eat the farmland. The farmland shrinks, and the country now imports more wheat than almost any nation on earth. Then there is the water itself. Egypt sits below the international water poverty line. The country faces a shortfall of around 7 billion cubic meters of water every year, a gap that grows wider with every birth, every heat wave, every drought upstream. The math is brutal. More people, less land, not enough water, a nation with its back against the wall. And there is a clock ticking behind all of it. Upstream on the Blue Nile, a giant dam has been filling for years, and Egypt no longer fully controls the flow of the river that gave it life. For the first time in 5,000 years, the country cannot simply assume the Nile will provide. Depending on a single river, guarded by neighbors, suddenly looks less like a blessing and more like a vulnerability. Egypt needed another option, a source of water and land that no upstream nation could ever switch off. So Egyptian planners looked west, into the empty Sahara, and asked a dangerous question. What if we could make the desert bloom, not with the Nile? The Nile is already stretched to its limit and fought over by 9 countries upstream. They would have to find water somewhere else and carry it somewhere impossible. The answer became the new delta, and it would demand a river that did not yet exist. The first problem was the one nobody could solve with money alone. Where does the water come from? You cannot pull it from the Nile. Every liter is already spoken for. You cannot pray for rain. Parts of this desert have not seen meaningful rainfall in living memory. The engineers landed on 2 sources, and both came with a warning label. The first is agricultural drainage water. When farmers in the old Nile Delta irrigate their fields, the runoff carries away salt, fertilizer, pesticide, and raw sewage. For decades, that filthy water simply drained into the sea, wasted, billions of cubic meters of it. The plan was to capture it, clean it, and send it west. The second source is fossil groundwater. Deep beneath the Sahara lie ancient aquifers, water trapped underground thousands of years ago, from a time when the Sahara itself was green. It is there, it is vast. But here is the catch that keeps hydrologists awake at night. It does not refill. Pump it out and it is gone for good. So before a single kilometer of river was dug, the engineers already faced their first crisis. Their cleanest, most reliable source was some of the dirtiest water in the country. And to use it, they would have to build the largest water treatment plant humanity has ever constructed. The site chosen was El Hammam, near the Mediterranean coast west of Alexandria. And what rose there does not look like a water plant. It looks like a city. The El Hammam facility covers more than 320,000 square meters. That is over 40 football fields of pumps, tanks, and filtration basins working in sequence. It processes 7.5 million cubic meters of water a day. To picture that, imagine draining 3,000 Olympic swimming pools every 24 hours. The dirty drainage water enters at one end, thick with sludge and chemicals. It moves through screening, then vast sedimentation basins where the heavy filth sinks to the bottom, then biological treatment, then disinfection. Machines here move water at a rate of nearly 87 cubic meters every second. The sludge scraped out of it is measured at over 670 kilograms per second. Think about what that means. This plant does not just clean water, it manufactures it. It takes a poison, water so contaminated with salt and sewage that it was considered worthless, and it hands back a resource clean enough to grow food. At a scale no facility on the planet has ever attempted. The engineers describe the interior as a canyon of concrete tanks, so long that workers use vehicles to travel between sections of the same building. When it was finished, Guinness World Records certified it 4 times over. The largest water treatment plant on Earth, the largest sludge treatment operation, the largest epoxy-coated surface area ever applied to a structure, sealing the concrete against corrosion, and the most operationally robust facility of its kind ever built. Here is the detail that stuns most engineers. It was built in 24 months.
Reroute the flow through channels 4 and 5 immediately. That might destabilize the east clarifiers. We have to risk it. The turbidity levels are rising too fast.
A structure this size would normally take twice as long. I am standing at the edge of one of the settling basins, and I cannot see the far side of it. It just disappears into heat haze. It does not feel like a building. It feels like a landscape. Staggering, but cleaning the water was only half the battle. Now they had to move it, and the water had to go uphill. This is where the new delta stopped being a big construction project and became something close to an engineering paradox. The clean water sat near the coast, at sea level. The land they wanted to farm sat inland, on a desert plateau, roughly 100 meters higher. Water does not flow uphill. Everyone knows this. So the engineers had to force it. They built a chain of 13 massive pumping stations along the route. Each one seizes the water and shoves it higher, station after station, lifting the entire river 100 meters into the desert. It is like carrying a lake up a 30-story building and then doing it again and again without ever setting it down. Consider the engineering problem hidden inside that sentence. To lift 7.5 million cubic meters of water a day requires pumps of monstrous power, and pumps that powerful generate monstrous force in return. Push water too hard, and the pressure can hammer a steel pipe apart from the inside, a phenomenon engineers call water hammer, where a surge slams through the line like a battering ram. So every station had to be tuned to hand the water gently to the next, matching pressure and flow across the whole 100-kilometer climb. Get one station wrong, and the shockwave could travel down the line and tear the river open. And the pumps cannot rest. Not for an hour. If the pumps stop, the river stops, and the water begins draining back downhill toward the sea, undoing the climb. So the stations were built with backup upon backup, redundant pumps, and independent power, because in this desert, a failed pump is not an inconvenience, it is a dying crop. And this is where the critics started shouting. Because pumping water uphill is not a one-time cost, it is forever. Those pumps must run day and night for decades, consuming staggering amounts of electricity. One economist put it bluntly. You are not just building a river, you are signing up to pay its energy bill for the rest of the century. The cost projections began to swell. What started as an estimate near $5 billion crept toward 15. The pumps were a big reason why, but the engineers pressed on, because a pump is useless without something to carry the water, and the channel they had to build would become the largest artificial river in the world. Now came the river itself, and the desert fought back at every meter. The main channel runs for over 170 kilometers overground, a canal slicing dead straight through the sand. But an open canal in the Sahara has an enemy that never sleeps: evaporation. In 50-degree heat, an exposed channel can lose a shocking fraction of its water straight into the sky. Every liter lost to the sun is a liter pumped uphill for nothing. So for long, exposed stretches, the engineers went underground. They buried enormous pipelines beneath the desert floor, hiding the water from the heat entirely. Kilometers of it threaded under the sand. It is why the full network of channels and pipes stretches well past 300 kilometers, even though the visible river is shorter. Then there was the ground itself. Digging a canal through soft desert sand sounds easy. It is a trap. Loose sand collapses, walls slump. A channel dug in the morning can be half filled by evening wind, and there is a second, sneakier enemy under the ground: seepage. Water sitting in bare sand simply soaks away, vanishing into the ground before it ever reaches a field. To hold the river in place, crews lined the canal with concrete and sealing membranes, locking the water in and the sand out. That lining is not decoration. It is the difference between a river and a puddle that disappears. The buried pipeline sections were their own ordeal. Enormous pipes, wide enough to walk through, had to be lowered into trenches, dug in shifting sand, joined watertight, and covered again, all in an environment where the wind erases your worksite overnight. Every joint is a potential leak, and a leak buried under meters of sand is nearly impossible to find. The crews were essentially building a subway for water, in a place with no roads, no power grid, and no mercy from the sun. And they had to do all of this in an environment openly hostile to human beings. Summer temperatures on the plateau climb past 50 degrees Celsius. There is no shade, no towns, no water except the river they were building. Workers, fuel, concrete, food, every bolt and every meal had to be trucked in across 100 kilometers of open desert. Progress was measured in brutal increments: 65% of the open channel here, 35% of the buried pipe there. Slowly, a blue line appeared on the satellite maps where there had only ever been beige. I am standing on the concrete lip of the main canal now, and the water below me is moving fast, clear, and utterly out of place. On my left, green. On my right, dunes to the horizon. The line between them is as sharp as a knife. It is one of the strangest things I have ever seen. But even as the river filled, a shadow hung over the entire project. Egypt had tried this before, and the last time, it failed. To understand the fear surrounding the new delta, you have to go back to the 1990s, to a project called Toshka. Egypt's leaders back then had the same dream: pump water into the western desert, build a new civilization in the sand, ease the pressure on the Nile. Toshka was going to reclaim vast tracts of desert. Billions of dollars went in. Canals were dug, pumping stations rose. And then, slowly, it withered. The water was too expensive to move. The land was harder to farm than anyone admitted. The grand new cities never came. Toshka became a byword for ambition that outran reality. So when the new delta was announced, the ghosts of Toshka were everywhere. Critics asked the obvious question: why will this time be any different? The engineering is more impossible, not less. The costs are higher, the water sources are riskier, and the aquifer problem was the sharpest fear of all. Satellite studies showed that some of the groundwater feeding the scheme comes from those ancient, non-renewable reserves. Pump too fast, and you drain a savings account that took 10,000 years to fill and will never be refilled. Turn the desert green today, and you risk turning it brown again in a generation. This was the crisis at the heart of the whole endeavor. Not concrete, not pumps, not heat. The question of whether the water would last. The engineer's answer was to lean hard on the recycled drainage water, the source that renews itself every season as long as the Nile Delta keeps farming. The fossil water would be the supplement, not the foundation. Whether that balance holds is the multi-billion-dollar gamble the entire new delta is riding on. And that gamble raised the cost again. The more the plan leaned on treatment rather than free groundwater, the more plants, pumps, and power it demanded. The figure that began near $5 billion climbed past 10, then toward 15 billion and beyond, as the true price of doing this, the sustainable way, came into focus. Cheap water in the desert, it turns out, is a fantasy. The only water is expensive water. The only question was whether Egypt could afford the bill and whether it could afford not to try. Standing out here, you feel the weight of that bet. There is no plan B for a country running out of room. Either this river works, or 100 million people keep crowding onto a ribbon of land that cannot hold them. The engineers know it. You can hear it in how they talk about the water. Not as a project, as a lifeline. And yet, despite the ghosts and the warnings, the river kept advancing. Because the payoff, if it worked, would rewrite the map of Egypt. The breakthrough came when the pieces finally connected. The El Hammam plant roared to life, cleaning its millions of cubic meters. The 13 pumping stations took hold of the water and began the long climb inland. The river filled its concrete channel and pushed west, past the point where every previous attempt had died. On the 17th of May, 2026, Egypt's president formally inaugurated the new delta. The largest artificial river in the world was open, carrying treated water into a desert that had been lifeless since before the pyramids. And behind the river, the transformation began. The target is enormous, 2.2 million fedans, around 9,000 square kilometers of former Sahara, converted into farmland, fields of wheat and corn and fruit planted in soil that had never grown anything. The scale of the ambition is hard to hold in your head. This single project aims to expand Egypt's total farmable land by more than a third. In a country where usable land is the most precious resource there is, that is not an improvement. That is a new Egypt grafted onto the old one. The human numbers are just as staggering. The construction alone created over 10,000 direct jobs, and studies estimate hundreds of thousands more in the farms, factories, and towns that will grow up around the water. Entire new cities are planned along the channel, communities that will live in a place their grandparents crossed only to die. The strategic prize is food. Every ton of wheat grown here is a ton Egypt does not have to import, does not have to buy on a volatile global market, does not have to beg for in a crisis. For a nation of over 100 million people, that is not agriculture, that is security. And the river will not only grow crops, it will grow cities. West of Cairo, developers have begun building a brand new metropolis called Jirian, a name that means, fittingly, flow. A man-made Nile channel will run straight through its heart, occupying nearly a fifth of the entire city, feeding the farms around it and cooling the streets. The plans are almost hard to believe. Room for up to 3 million homes. 80-story towers rising out of ground that was empty desert months ago. Universities, hospitals, and 250,000 jobs, all clustered around water that did not exist in this place until humans decided it would. It is the oldest idea in Egyptian history, restated in concrete and steel. Where the water goes, life follows. 5,000 years ago, that water was the natural Nile, and it built one of the first great civilizations on Earth. Now the water is being routed by pumps and pipelines, and Egypt is betting it can build a second civilization beside the first. I am standing at the edge of one of the first cultivated fields now, where green shoots are pushing up out of ground that was pure June 18 months ago. Behind me, the desert. In front of me, a farm, and running between them, a river that 100,000 people willed into existence out of nothing but sand, concrete, and refusal. I genuinely cannot believe what these humans have built here. The new delta is not finished. The channels are still extending. The farms are still being planted. And the great question, the one about the water, will not be answered for years. But whatever happens next, the fact of the thing is undeniable. In a stretch of Sahara that had been dead for 10,000 years, there is now a river, built uphill, fed by the largest treatment plant on Earth, carrying water to soil that is turning green for the first time in human history. The desert said it was impossible. Egypt is building it anyway.